Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 6, 2025, about 10 days ago. This paper introduces a new method that improves factual accuracy on the truthful QA benchmark by up to 6.4% over the next best approach. The paper is titled LayerCake, Token-Aware Contrastive Decoding Within Large Language Model Layers, and it achieves this without any extra model training, which is really impressive. The core idea is that different types of tokens, like punctuation or key concepts, have their biggest impact at specific depths inside the model. So this figure really visualizes that core idea using a clever layer cake metaphor. You can see the model's layers are stacked just like a cake. In the normal process on the left, the model's focus or its attention weights shift as information moves down. Early layers look at punctuation, while deeper layers focus on conceptual tokens like peaches to produce an answer. The final scores for each possible word are called the output token logits. Then, they create a messed cake by disrupting this process, which generates a less factual answer. Building on that messed cake idea, this figure really gets into the details. First, the authors categorize the input words into types. You have punctuation, then functional tokens, which are just grammar words like what and is. And finally, conceptual tokens, which carry the key meaning, like sport or Japan. The heat map on the left shows that normally these conceptual tokens get the most attention in the middle layers. But then, on the right, they intentionally suppress that specific attention. And that's enough to make the model predict sumo instead of baseball, proving their point perfectly. So these next charts really quantify that effect. The line graph on the left plots the average attention received by each token type across the model's layers. Attention is basically how the model decides which words are most important to focus on at each step. As you can see, punctuation, the yellow line, dominates the very early layers, while conceptual tokens, the blue line, rise to importance in the middle. Building on that, the bar chart on the right shows the impact of suppressing that attention. The biggest accuracy drop happens when they disrupt conceptual tokens in those middle layers. This confirms their theory and gives them the perfect tool to create that messed output for their contrastive decoding method. Alright, so this table really puts all that theory to the test. It compares their LayerCake method, which is listed as ours, against other decoding strategies on several benchmarks. These benchmarks, like Truthful QA and Strategy QA, are basically just standardized tests for factual accuracy and reasoning, and the results are pretty impressive. Across different models, like Llama 2 and Llama 3, their method consistently scores the highest. For example, on the Llama 3 model, they see a nearly 8% jump on the Truthful QA test, which is a huge improvement. And this next table shows that the LayerCake method's success isn't just a one-trick pony. Here, they apply it to the Llama 2.7b model across a whole range of other benchmarks, like Trivia QA and Hotpot QA. They use two main metrics, exact match, which means the generated answer has to be perfect, and the F1 score, which gives credit for partially correct answers. And as you can see, their method, listed as ours, consistently outperforms the others. Look at Trivia QA, a more than 10% jump in exact match. It's really impressive. Okay, so this next table is what's called an ablation study. It's where the researchers take their method apart to see which pieces are doing the heavy lifting. Here, they compare the effect of suppressing conceptual tokens, that's the C column, versus punctuation tokens, the P column, at different layer ranges. And the results perfectly match their LayerCake idea. In the early layers, from 0 to 4, suppressing punctuation gives the best scores. But in those crucial middle layers, from 5 to 16, suppressing conceptual tokens is what works. This really proves their theory of layer specialization. So that ablation study really brings it all together, confirming the whole LayerCake theory. The key takeaway is that LLMs process information in specialized layers, punctuation for structure early on, and conceptual tokens for meaning in the middle. By using a clever technique called contrastive decoding, where they create a bad answer to steer the model away from, they can significantly boost factual accuracy without any expensive retraining. It's a very elegant and efficient solution to the hallucination problem. That's all for this week's AI Research Roundup. Thanks for tuning in.